Okay, let's take a look at graph using intercepts. Second day. So as a quick review, let's just look at the word intercepts. When you hear the word intercepts or you read the word intercepts, immediately you should be thinking where the line crosses the x-axis and where the line crosses the y-axis. If the line crosses the y-axis, or sorry, is on the y-axis, you'll have x equaling 0 and y will have some sort of value. If you're on the x-axis, then the y value must be 0. And the reason is because, taking a look here, if I'm on the x-axis, y controls up and down movement, but I'm on the x-axis, therefore I have not gone up nor down from there. And conversely, if I'm on the y-axis here, for example, I haven't gone left and I haven't gone right. I am stuck on the y-axis, so my x value is 0 because x controls horizontal movement. Okay, so that's a quick refresher of what we mean by intercepts, lines that are are on the axis, either the y-axis or the x-axis. So if we have an x-intercept of 2, an x-intercept of 2 is the same thing as saying 2, 0. An x-intercept of 3 in this case is like saying 3, 0. Okay, so we have an x-intercept. Let's just work with the x-intercept of 2 so far, and that would be right here at 2. Or 2, 0. And it says here that the y-intercept is 5. So we're going to be up here on the y-intercept at 5. And then we're going to graph a line. I don't like that line. I'm going to graph a line through those 2 points. Let's try that one more time. Okay, and then that is our line running through x equal 2, x-intercept of 2, and a y-intercept of 5. If we have an x-intercept of 3, let's try graphing that. I'm going to move this out of the way so we have some room. I'll try a different color. So when the x-intercept is 3 and the y-intercept is none, for it to have no y-intercept, we're going to run we're going to run vertically. Oops. There we are. We're running vertically through x equal 3. In this case, we will never touch the y-axis. We're running parallel to the y-axis, and the x value is 3. So along the pink line, the x value will always equal 3, but we'll never touch the y. We'll never have a y-intercept because it runs parallel to the y-axis. In the next example, we have the x-intercept being none, and the y-intercept is -4. So here we are, y-intercept of -4, but we're also not passing through, we're also not going to pass through the x-axis because we are parallel to the x-axis. And this line will never touch the x-axis, but it will have a y-intercept of -4, and along that line, y value will always be -4. Okay, let's look at converting equations from slope y-intercept form into standard form. Here we want to get rid of the denominator. The denominator is 5. The common denominator is also 5. So we're going to multiply everything here by 5. And when we multiply each term by 5, what we get is 5 times y is 5y equal, and this 5 and this 5 cancel each other out. And we end up with 3 times x. And then minus 7 times 5, which is minus 35. But before we continue, we want to make sure we understand what standard form is. Standard form is when we have a value in front of the x, or something x, plus some number y plus c equal 0. So in this case, we have our something x, and we want the a value. Remember, the a value must be positive. So we already have 3x, but we need to put that in proper order. The next term is something y. In this case, we have 5y. So we need to subtract 5y from both sides, or sneak this in here. So what we're going to do is we're going to subtract 5y from both sides. That will leave me with 0 here. That will leave me 0 here, equal 3x. And I bring the 5y over, negative 5y minus 35. And you might be thinking, hang on a second, I thought it was ax plus by plus c equals 0 on the right-hand side. Well, if I read this 0 equal ax plus by plus c, it'd be the same thing. This equals 0, whether I write it like that, or I write it like this, it still equals 0, or has a value, an equivalent value of 0. Okay, so again, when graphing using intercepts, a good strategy is to, that's right, a good strategy here is to write the question twice, and in doing so, we're going to sub in 0 for x, and then we're going to sub in 0 for y so that we can find our intercepts. Remember, an intercept is also a coordinate. So if I sub in 0 for x, I get 0 minus 2y plus 4 equals 0. Then I'm left with 0 minus 2y is minus 2y. And I'm going to bring that 4 over and becomes negative 4. To isolate y, we divide both sides by negative 2. Negative 2y divided by negative 2 is simply y. And negative 4 divided by negative divided by negative is positive. So 4 divided by 2 is 2. So my answer is actually when x is 0, y is 2. And I want you to get in the habit of writing a coordinate as your intercept, please. So we have this. Now we're going to do the exact same thing, except we're making the y value 0. And so we'll have x minus, and then 2 times 0 is 0. So we'll have x minus 4 equals 0. We'll send this 4 over, and we'll get x equal 4. So x is 4 when y is 0. And now we have our two coordinates, 0, 2, and 4, 0. So let's go over here, and we'll graph our line. So 0, 2, and 4, 0. And there we are. Okay, that's graphing using intercepts. Let's try this one more time. If I were you, I'd pause the video here and see if you can do this on your own and get the same answer and the same graph. So remember, we want to start by writing the equation twice. We're going to sub in 0 for x first. And we'll have negative 6y equal 12. We'll divide both sides by negative 6. And y will equal negative 2 because positive 12 divided by negative 6 is negative 2. And so when x is 0, y is negative 2. Then we'll sub in 0 for y equal 12. And then we get 3x equal 12. Divide both sides by 3. X equal 4. So x is 4. And y is 0. So now we have our two coordinates, 0, negative 2, and 4, 0. So there's our 4, 0, and 0, negative 2. Let me graph that line. Not a fan of that. There we go. And there's our line. Hopefully you got the same one. Let's scroll that. There's that one as well. And here we go. Communication. Explain and use sketches to support your answers to each question. Is it possible for a line to have no x-intercept? So I've gone ahead and answered these if you'd like to copy. Yes, it is possible because a line can run horizontally and the slope would be 0. That really means that the line runs left to right like this. And let's see, here's my Cartesian coordinate system. So there's a line that's x, 1, 2. Let's say the y-intercept is 3. So this way it would have no x-intercept. So it is my short form for parallel. It is parallel to the x-axis. It is parallel to the x-axis. Is it possible for a line to have more than one x-intercept? Well, no, generally not if it's a straight line. However, if you think about, so you might be thinking of a line like this. It's going to have one x-intercept right there, and of course it's not going to bend backwards and touch the x again because it's a straight line. However, having said that, an equation of y equals 0 would be a line running through, and I'll draw this in blue, an equation of y equals 0 would be a line running horizontally through the x-axis. In this case, it has an infinite number of x-intercepts. So that would be y equals 0, because the y-intercept would be 0, which is the origin right there. Is it possible for a line to have no x-intercept and no y-intercept? Well, if the line, technically, if the line runs through the origin, we can have no x-intercept and no y-intercept. So in this case, we have an equation like y equal x, and there is no x-intercept and technically no y-intercept. So it is possible. All right, and that's it for today. Hope that makes sense, and we'll see you in class.